Hypothalamus Artificial Intelligence, HI. It presents companies in the process of digital transformation, its offer of professional services and the supply of algorithms of highly complex multi-problem mathematical models. These services are called scientific marketing, managed demand by the seller. To provide these services, HI is supported by its business partners, GAMS, IBM and TD SYNNEX, all of which are producers of artificial intelligence technologies. HI is a company at the forefront of high-performance artificial intelligence. Demand characterization, managed by the seller. Application of marketing and sales sciences. It is common for marketing and sales departments not to consider this area of knowledge to have a scientific basis, tending to think that its behavior is fundamentally socioeconomic, and can only be managed with mental models. However, traditional artificial intelligence, supported by pattern recognition, has been changing this position and has shown that this type of tool is necessary in modern organizations. The incursion of artificial intelligence for decision-making is an approach for companies to support their decisions with tools that describe marketing and sales processes and help optimize the portfolio of decisions that maximize the revenue of the organization as a whole. Impact of factors. HI-DEM solves quantitatively answers questions such as: what is the immediate effect of marketing mix decisions, 2-by-1 promotions, sharp events, ad spend? What is the impact of cyclical seasonality on demand, end of the month, fortnight, Easter, day of the week? What is the impact of promotions in subsequent periods, pantry load? What is the effect of product characteristics, colors, and POS on demand, local size? What is the natural growth level of demand, without considering seasonality or marketing events? What is the impact of external variables, such as climate, national or regional GDP, or population on demand? What is the price-demand elasticity of each reference? Does this elasticity have a seasonal behavior? If we look at the demand chain, forecasting models should feed into scientific marketing and sales management models. These models are: tactical planning. Market share optimization optimizes market attention, considering models that explain the market share of products and regions. Marketing mix optimization optimizes the distribution of marketing expenses in the different alternatives, considering the elasticities of the different media, and inventory policies. Operations programming. Revenue management, also known as price optimization, determines dynamic pricing policies for products throughout their life cycle, and over time seasonality. Customer management, artificial intelligence models aimed at determining the behaviors of groups of customers, or specific people. Product portfolio management aimed at supporting the sales work of salespeople, at the times when they must serve customers, and campaign optimization, optimization of product promotion activities, can be considered as part of the marketing mix models. The projection of aggregate demand in a sector, an area, a manufacturer, a category or a channel, or combinations of the above, has two alternatives. From the bottom up, aggregate demand projection is done at the lowest level of the cluster, at the atom level, which implies having the capacity, data, and computing power to estimate a statistical model for each demand series of atoms that relate to SKUs at a point of sale during a period, an hour, a day, a week, or a month. Top-down. The projection is made at the level of aggregate demand, and then it is disaggregated at the level of atoms, for which it is necessary to have disaggregation rules, which are not obvious, and therefore are empirical rules. If possible, HI prefers the bottom-up method. From the point of view of the volatility of the data series, and therefore, of the projections, volatility is expected to decrease at the aggregate level. However, the above is true if the correlation of demand in atoms tends to be neutral or negative. If the correlation is positive, the volatility of aggregate demand will be higher. The demand for products, and/or services, is the result of the integrated impact of multiple factors. These can be grouped into economic prices, product and POS attributes, competition activities, advertising, and seasonality of multiple types. This means that a demand model that only considers consumption series, and possibly sales prices, leaves out important effects that affect demand. For this reason, models based on simple time series, such as Box and Yankees, need to be extended to contemplate all the effects. The high-dem model allows the inclusion of elements of different types, to represent processes of demand for goods, and/or services, with very different behaviors. The generic equation to explain the average demand is made up of the following additive components. Elasticity of demand with respect to price. Cannibalization. Pantry loading. Lost demand. Temporal trend. Periodic seasonality. Seasonality due to cyclical events. Commercial initiatives. Effects of global exogenous variables. Effects of regional exogenous variables. Autoregressive effects. Effects of the moving average. Effects of product attributes. Point of sale attribute effects, and zone attribute effects. The two main outputs of the high-dem model are characterization of the competition, and characterization of customer demand. The model summarizes the organization's knowledge about the behavior of its customers and competitors, using algebraic equations, which characterize the mean and variance of the demand process, so that the characterization is probabilistic. The characterization of market share aims to determine which are the variables that explain the behavior of the demand of a manufacturer, or a brand, based on the characteristics of market trends, the manufacturer's decisions, the decisions of the competition, and consumer preferences. The graphs present the adjusted models, using Nielsen databases, of the same product, in two different markets, for the same distribution channel. This information can be included in a market share optimization model to determine which market to invest in, how much money to invest and under which business initiatives. To estimate all the impacts, more specifically the elasticities of demand with respect to factors, it is necessary to add to the company's databases from different sources, depending on the type of market. As an example, the image presents information from the following types of databases: historical sales information, hydroclimatic databases, socio-demographic information, syndicated database, like Nielsen, promotion history, own and competitor, and seasonal events. With appropriate modeling, it is possible to decompose demand as the sum of the impact of the different factors, this for each product, each point of sale, and each period. The graph shows the demand curve that has been broken down into base demand, pricing policy and competitor promotions, 3 factors, product features, seasonality, and the company's marketing policies, 5 factors. Factor elasticities, which are under the control of the company, are essential to optimize the marketing mix and market share. This implies that the process of sampling events, and in general of obtaining information, must consider the activities that are planned to be carried out in the future. The graph presents a projection obtained with the high-dem model for a product at a point of sale. The series of claims has broken down into temporary trend, plus 1.6 kilos per month. Monthly averages, in the second row of results, reference month December, seasonality, week, only present in the year 2011 to 2012, effect of 2 promotions, Promo 1, minus 11.45, and Promo 2, plus 6.24. The consumption data are given in kilos per person. From the point of view of organizational management, it can be said that the demand model and the production and sales, SAND-OP, model are the hypothalamus of the organization. The way these two models are handled is the cornerstone of successful planning. A very good demand forecast, followed by regular production planning, or regular demand prediction followed by very good production planning, will put the organization at risk. The modeling effort must be done in both directions. The optimization models for industrial value chains are divided into 2 large groups, supply and demand. The image presents a possible connectivity of demand models, which determine the market demand that the company will serve. This architecture is not unique and is the result of building an artificial brain for the organization. On the other hand, we have supply models, that is, those that define how the supply of products that will be sold in the market occurs.
La conectividad de los modelos de optimización para cadenas de valor industriales es lo que define la arquitectura del sistema de soporte de decisiones, y en términos de los cerebros empresariales, corresponde al córtex artificial, que determina cómo se conectan las neuronas matemáticas, problemas matemáticos, que conforman el hipotálamo artificial, que se encarga de manejar todos los modelos de la organización. Estos modelos deben atender toda la cadena jerárquica de toma de decisiones, esto es, estrategia, táctica y operación. Y debe cubrir todos los negocios y regiones en los que participa la empresa.
The fundamental planning models are the demand model, DEM, which characterizes customers and competition, and the sales and operations planning model, S&OP, which optimizes aggregate output for a given level of sales. Without these models, an organization is adrift. To do so without mathematical models is to leave a lot of money on the table. The image presents the view of the same model system, not as a flow of processes, but as two artificial hypothalamuses composed of two sets of models, working in a coordinated, autonomous, real-time way and distributed across multiple processors. The S&OP model summarizes the organization's knowledge of its production system. It takes the supply chain and demand forecast as input and produces the production plan. Today, thanks to computational power, that proves to be overcome, and it can be said that this process is easily carried out for an organization of any size. It is a test passed. Defining a strategy for planning is the first step in shaping the market. There are two basic strategies: demand-driven, consumer demand determines what will be sold in the market, or driving demand, what is convenient for the producer to produce determines what will be sold in the market. Hy believes that in seller-dominated markets, driving demand is the smart strategy. Market pull demand or demand-driven. The term demand-driven was invented in 2002 at PeopleSoft. It was and still is defined as detect changes in customer demand, then adapt planning and production while tapping suppliers, all in real time. Under this approach, the organization's demand planning is done by the market, which determines what the organization should produce. This means that the market potential establishes the value of production. The following describes what the traditional modeling of the integration of the two models might be. For all products, at all points of sale, for each of the periods of the planning horizon, the following process is carried out. The DEM model is used to estimate the parameters of demand models, with the parameters estimated for the mean of the probabilistic process. Demand projections are made. After a review of the projections, the pertinent adjustments are made, and the planning of the demand to be met is formalized. The next step is to use demand projections to determine the inventory policies to follow during the planning horizon. The final step is to run the S&OP model taking as input demand projection and inventory policies. The result of the S&OP model will be the plan of the goals, production and distribution, to be achieved during the planning horizon. This process, despite being carried out with advanced mathematical models, can have many coordination problems. Some of them can be: as demand planning was carried out without considering all the constraints that must be met in production, it may not be possible to meet it. Because demand planning was carried out without considering the economics of costs and benefits, it is possible that products may be produced that are not suitable, often because they force production to meet recklessly made commitments. Minimum inventories are planned for all products, even those that cannot be sold, which can produce more stress on the production system. For example, a shortage in working capital, and inventories that have not considered the management of storage capacities, leading to unfeasible inventory policies. The above are some of the problems of coordinated planning, which is not optimized in a comprehensive way, which are solved with holistic planning. Driving demand is used by Hy to name the approach of integrated supply and demand planning. It can be defined as demand controlled by the seller, or by the producer, who decides from the potential demand what, product and point of sale, how and when it should be satisfied. Under this approach, the organization's demand planning is carried out by the organization, deciding what to offer to the market, taking its potential demand as a reference, but deciding, autonomously and optimally, which demand it should satisfy. This means that the market potential sets a ceiling for production. The modern approach is to integrate all three models into one, so that planning is done holistically and not segmented into three separate models, which don't see what's happening next door. The process to follow is: the SANDOP model is modified as follows. The algebraic equations of the demand models are read, and not the projections. This is equivalent to bringing the demand model to the SANDOP. In this way, the integrated model will be able to make demand projections internally. Demand equations are expected to include factor elasticities that the firm controls, so that the model decides the optimal value for these factors. The inventory model is integrated into the SANDOP model. With these changes, the SANDOP model will produce, as part of the optimization process, the optimal projection of demand, defined as the projection that is feasible to meet, and that produces the greatest economic benefits for the company, and optimal inventory policies, respecting storage capacities, and establishing policies, only for those products that are part of the optimal demand projection. The fundamental result of the SANDOP model will be the same as in the traditional method. The plan of the goals, production and distribution, to be achieved during the planning horizon. But it will be a realistic, feasible and economically optimal plan. In summary, sales and operations planning requires three fundamental mathematical models: DEM, S&OP, and INV. In traditional planning, market demand-driven, the marketing department establishes the objectives that production must meet, without looking at the marginal cost, profitability and viability of production, since there is no feedback from production to sales. Under the driving demand policy, the feedback loop is closed, and an optimal production plan is obtained. For more information, you can write to the email that appears on the screen. Like Herbert Simon, Hypothalamus Artificial Intelligence believes that computer-based mathematical modeling is the greatest invention of all time. Thank you for your attention.